Wonderful enough. How are you? How are you, everybody who is watching this fantastic program? I'm very happy to have you. You are warmly welcome into one of our online advanced school that's called the Tanzania Online Advanced Secondary School in square bracket Olenjolai&Nekinyi. I would like to take this opportunity to welcome you into one of our online institutions that called the Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai&Nekinyi. Yeah, this is Sir and Engineer Olenjolai from the beautiful country that called it Tanzania. I have a good news today for you, for everybody who is watching this program. I'm a Tanzanian, and this is our national flag. We'd like to welcome everybody who love our country where God used to live. So I'm not actual that I'll be a teacher in these programs. I'll be teaching you about advanced mathematics and also basic engineering and scientific mathematics for the ordinary diploma. I would like to take this opportunity to welcome you into two of our online programs. I would like to take this opportunity to welcome you into one of our online schools that called Tanzania Online Advanced Secondary School in square bracket Olenjolai&Nekinyi. Simultaneously, I would like to take this opportunity to welcome you into one of our online institutions that called Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. So whether you are an ordinary diploma student in engineering and science, this is the right place for you. Whether you are a student who is pursuing advanced educations in advanced educations, when you are with mathematics as one of your principal subjects, especially for the four combination PCM, PCB, PMC, and EGM, this is the right place for you. Again, if you are not among those listed, we are still very important for this program because we have a good news for you. So you have to stay tuned because you can find yourself you are fitting in a particular place or in a particular system in order for you to get success for the rest of your life. So what are we doing in Tanzania Online? The first questions in your mind, what are we doing in Tanzania Online Advanced Secondary School in square bracket Olenjolai&Nekinyi? And then for the ordinary diploma students, they used to ask themselves, what the purpose of Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai? Well, both the institute, the online institutions and the online schools are just they have a clearly defined purpose for them to exist, for them just to exist and actually that to exist for the rest of the life of the mankind. And this is an assignment. We have a responsibility, we have an assignment from God to teach and train some group of students who will be ready to extract knowledge and wisdom from the formal and informal classroom instructions, and combine also with the knowledge, wisdom, and understanding that we are going to teach them to extract it from the Word of God written in the Holy Bible in order to solve real life problems. So for example, if you are an advanced secondary students who is pursuing science and mathematics, there are some real life problems need scientific solution, need advanced mathematics solution. So you have to think differently, and we are going to challenge you. However, that will be also focusing on helping you to pass your exams. But that's not the end for these programs. If this program or these online schools used to go extraordinary to what your physical schools you used to experience. So you used to deal with the purpose of the students and not just the certificates and paper, because those are numbers. Used to deal with the mind of people. That's what we are doing here, because even ourselves, God has been dealing with our mind and not our certificates. It doesn't mean that certificates, they don't have the year contributions, but they are not the main character for this program. They're not the main character for the mankind life. That's why that nowadays we have so many educated people, but we have less successful people through the education. Okay, so similarly, that's what we are doing in Online Diploma Polytechnic Institute of Tanzania. So basically, we are focusing on the 4 skills. Number 1, extracting knowledge, wisdom, and understanding from the classroom instructions, formally and informal. For advanced school, it means that you're extracting those information in science and advanced mathematics. Or for those who are in ordinary diploma, they're extracting that information from engineering and core modules and also engineering fundamental modules. So that's number one. Number two, we teach you to extract knowledge, wisdom, and understanding from the Word of God. And number three, we teach you how you can combine them. And number four, that's the most important, then we teach you how you can apply the knowledge, the two knowledges, the combined knowledge now with the combinations of the mind and the combinations of the spiritual or of the spirit, then to solve real life problems. We have so many different real life problems that are waiting solutions or are really demanding solution. Myself, Sir Olenjolai, I'm a product of what I'm telling you right now. So I have taken more than 5 years to achieve just a primary objective in this aspect I'm telling you. So what I'm telling you, it might take a number of years or number of months. It depends to your speed and depends to your sensitivity, depends on your capacity that God has created to you. But believe me that this is possible, what I'm telling you. So that's very important for you. So another thing is the topic of the day and the subtopic of the day and also the session of the today has experienced the intersection. So I'm a teacher of Online Diploma Polytechnic Institute of Tanzania. I thank God also by His own grace, I'm a teacher of Tanzania Online Advanced Secondary School. So the concept I'm going to teach today, I used to teach in both schools. So that's why that I say I should combine, to me, I should teach ordinary diploma students at the same time I'm teaching advanced secondary students. So if it is physical, I can mix them because I know the syllabus of ordinary diploma according to the NACTE, and I know the syllabus of advanced mathematics according to the Tanzania Institute of Education. So there is a great intersections in many aspects. So in order to make sure that we deliver intensive materials within the time that the limited time that we have, that's why that we are going to mix you. And it's true because both are the graduates, so it means that the advanced secondary students are the graduate of ordinary secondary education, and even also ordinary diploma are the graduate of ordinary secondary education. So there is a close relationship between the modules or courses of ordinary diploma and advanced mathematics. That's what I'm telling you because I thank God I studied both of the aspects. By God's grace. I studied the courses of ordinary diploma informally. I've never studied any programs of ordinary diploma. I thank God by His grace. I went through all the modules, all the important contents that they are covering, so I know the limitation. I've been teaching physically for 3 years. And I thank God by His grace, I did my advanced mathematics from 5 and from 6 in Tanzania. So I know what you have to do. And the good thing also, I still have some of the written documents, for example, the syllabus and the curriculum, which actually are guiding me and aligning me to what should I teach you and what should I not teach you at this moment. So another thing which I want just to tell you, and then we are going to start the session, because this is not a political class, it's engineering class, it's engineering mathematics class and also advanced mathematics class. Let me talk for a few minutes about registration to ASO. So registration to ASO or registration to Online Diploma Polytechnic and the Polytechnic Institute of Tanzania, square bracket. Or to ASO, these are abbreviations of Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. ODPITO, these are the abbreviations of Online Diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. So the following are simple procedures that you have to follow. Within a minute, you do the permanent registration and you'll be a member of our online institutions and also our advanced secondary school. The first is open an email. Okay, open an email, say email. So when you open an email, basically we have two famous emails, Yahoo and Gmail. So you can have one of them. It is free. You won't be charged an amount of money to have an email. I have both email, Yahoo. I have Yahoo email and the Gmail. And also the second step now, we ask you that to sign in by using your email. Sign in, okay? Sign in YouTube. So if you have email, just go there to the second step. If you don't have, just go into Google while your mobile device or your computer has an internet, and then you ask Google, how can I open a new email? Then you get the answer, or you see the procedures you follow. just you create a password, but keep your password please, because if you lose it, it's a little bit difficult for you to recover it. So sign in YouTube, okay? So sign in YouTube, YouTube system, okay? So after you sign in YouTube system, the next step, which is the third step right now, ladies and gentlemen, we have, when you are in YouTube now, you have to search it. You have to search it for ASO. Okay, you have to search to ASO if you are advanced secondary students, and also if you are ordinary diploma student, then you have to find on online diploma polytechnic institute of Tanzania in YouTube. Wonderful. So this is just within few seconds. You finish the search step. The first step. Then when you search it in, you'll see the icons. Most of them will see the icon. And then these icons, within the icons, or within these round icons, you'll find the national flag, like this one. Okay, you have to click that national flag. Then you find the names of each channel there, because these are the two different channels. Once you click, you are already in institution, or you are already in OT. Okay, you're already in OT. You are already in our advanced secondary school. So when you are in either, or you can visit both, you have to click once the word or the software button which has been written inside of it, subscribe. Say subscribe. Once you subscribe, you find that these buttons change its background color, and itself also will change into subscribed, and the bell icons appear here. So you have to click this bell. So once you've subscribed it, now the last step now, you say click bell click bell icon. Click a bell icon. So think that in bell icon is just like this way. Okay, bell icon. When you click, then you say that choose. You see three options. Choose the options of all. Then you are permanently you are permanently registered. So everything will be okay. You're finished to register. And the good thing that this is not like a formal schools or formal institutions where you spend a week, you spend just for registration, or 2 weeks for registration. Here you just spend, if you have an email, you just spend less than a minute. And when you do the registrations, next time, so there's no need for you to do registration. You just subscribe once, then it's over. Why should you subscribe? What it means of the word subscribe? Subscribe means that you are allowing the system, or that you have subscribed it, to give you information about the release of the new product. So in both online schools that you have and online institutions, we add at least one video in a day. Every day we have to add at least one video. In Tanzania Online Advanced Secondary School in square bracket Olenjolai&Nekinyi, we have also to add at least one video in online diploma polytechnic Institute of Tanzania in square bracket Olenjolai. So when you subscribe, whenever that you are online, anywhere at any time, even during the meantime, the YouTube community will give you notification that Sir Olenjolai has added a new video in his own online channel or online schools, so you may go through it. So you get notifications. There's no need of us just coming to your place physically and give you too much of announcement. The digital system will give you the information, so you have to go through it. Again, before I start the session, the way that in a physical classes, I used to give my students almost 30% of every sessions to ask me questions. How can you ask me questions with this program? That is a good system. That are good questions. Use the comment sections. Later on, as long as we go, I can add up another platforms which can allow I and you to interact, even in terms of sharing what you've written to me, so you can do the homeworks, and hence if you cannot write everything in the comment section, you just take a photo and then you send, possibly through the WhatsApp or through different platforms. So stay tuned. I will give you the updates once everything has been settled, so that we can interact more as well as we can, because I love my students to ask you so many questions. Do you love advanced mathematics? Do you love basic engineering and mathematics? Do you love basic scientific mathematics for ordinary diploma? Tell me in the comment sections, please, before I start teaching you. But whether you laugh or you don't laugh, just pay your attention for an hour later. Then you'll get excitation, we'll get transformations, which is the radical transformation. So let us go to the session. So when you go to the sessions, we have two departments. We have departments of advanced mathematics, and also we have departments of basic engineering and scientific mathematics for the diploma institutions. The subject is called advanced mathematics here in departments of advanced mathematics. But departments of basic engineering and scientific mathematics, the module is called what? So the module of course is called what? It's called the conics and differential equation. We are in chapter 1 for coordinate geometry 2, but we are in the second topic for the conics and differential equation, because this is conics. Coordinate geometry 2 it has the same meaning as its conics. Then we are in the subtopic of the parabola, while in ordinary diploma this is the topic. This is session 5, so we have already taught you 4 sessions you have to go through. And today we are going to teach about translated parabola, and these contents are for the pre-form 6 or form 6 students for advanced education, and these contents are also relevant for the second year or NTA level 5 students. You're a national international student. Let us go to the business. So to just do the quick review to link the today's session, okay, quick review of session 1 of the previous session. It was session 1 session 4. So in session 4 we taught you about lattice vector. So lattice vector, that was the heart of the course. So but before we taught you about lattice vector, first of all, actually that we did the corrections of the homework, that the revision, we taught you about the revision of what? Of standard equation of what? Standard equation of parabola, right? Parabola along what? Parabola centered at what? At origin, at 0, 0, right? So we dealt with positive y-axis, negative y-axis, then we dealt with positive x-axis, then we dealt with negative x-axis. That's what we've dealt. So basically, to remind you about the 4 equations, because this is very important, we say that the standard equations of the parabola along positive y-axis gives us y squared is equal to 4ax. The standard equations of the parabola, okay, the standard equation of the parabola along negative y-axis, this is giving us y is equal to negative 4ax. Again, the standard equation of the parabola lies along the positive y-axis. This is giving us x squared is equal to 4by. Then the standard equation of the parabola along the negative y-axis, this is giving us x is equal to negative 4by. So these are the very important equations that we taught you. But later on we taught you about focal chord, and then we say that focal chord is any focal chord. Focal chord is any line which passes through the focus of 40 of the parabola. So focal chord of 40 of parabola. So among so many focal chords, then we say we have one of the focal chords which is called the lattice vector. Say lattice vector. So lattice vector is a line which passes through the focus and perpendicular to the axis of symmetry of the parabola. And then in this concept, we taught you how determines the endpoints, okay, the endpoints of 40 of lattice vector. So the endpoints of lattice vectors depend whether the parabola lies along the x-axis or negative x-axis. If it's along if it's along x-axis, we say that its points or the endpoints is simply given as plus or minus 2a, 0 or a. Okay, no, this is if along x-axis it is what? A, then plus or minus 2a. If the parabola lies along the y-axis, then this is given as plus or minus 2b, then comma out, comma b. Am I right? Yes, I think that's what I told you, if I'm not mistaken. Yeah, it is a comma plus or minus 2a. Yeah, everything is okay. But later on, we discussed about length of lattice vector. So if the parabola lays along the x-axis, length of lattice vector is equal to 4 times a, constant a. But if the parabola lays along the y-axis, the length of lattice vector is equal to 4b. In case you missed the session 4, don't panic, don't get stressed. Everything's still in your hands, right? God loves you so much. So you have to just go into, if you're an advanced secondary student, go into one of our YouTube channels that called Tanzania Online A-Level Set School in square bracket OLENJOLAIM. Then you can access session 1, session 00, session 01, session 2, session 3, session 4, and even this one you find it there. Again, if you are an ordinary diploma students, you have to go into our online also our YouTube channels that's called Online Diploma Poly Institute of Tanzania in square bracket OLENJOLAIM. You will see the links, you will see even the names when we'll be adding some intro and outro of the entire video. So just have reviewed the entire video, you'll get correct information about the particular place. So you have to review this, then you'll find that this next concept will be a very simple. So today we are dealing with, this is session or lecture 5. Okay, so you can call this session or lecture 5. So it means that with regard of ordinary diploma, this is lecture 5. Okay. So let us go straight forward and deal with translated parabola. That's the concept that God has filled me or has anointed me to teach you today. Translated, say with me, translated parabola. So always, OLENJOLAI start with understanding the big picture. What is translated parabola? Why do we call it translated parabola? What are we doing? What is unique property? Parabola. Okay. What is translated parabola? Well, so the literature say that, and even the fact, translated parabola, okay, translated parabola simply say that is a parabola. So this is the parabola, okay, which has been, okay, so we got it, is the parabola. This is a parabola which its vertex, okay, which is vertex, or we call it center is not at origin. Aha. So where is it? It's any other points except its origin. So a translated parabola is a parabola which its vertex, I told you the meanings of vertex we defined in session 2 or in lecture 2. So its vertex or center of parabola is not at origin. Where is it? It's any other points along the xy plane. Wonderful. So if this is the case, if you are dealing with translated parabola, it means we do have a non-translated parabola. So we say that, for example, means that the non-translated parabola, okay, non-translated parabola can be shown here. Non-translated parabola, okay? So it's a parabola whose vertex is at origin. So this is the one that I taught you in previous session, but if you forgot, I'm here to remind you. Because God loves you so much. So for instance, this is y-axis, and this is x-axis, okay? So, you see, remember that I told you that every conic section, okay, parabola, hyperbola, and the ellipse, have a line, we call it directrix. Say directrix. Have a lines, we call it directrix. So 1, 2, 3, 4, So 1, 2, 3, 4. Okay, 1, 2, 3, 4. So this will be the focus. Okay, so we say that this is origin, or this is 0, 0. Remember that. So we can have or we can have a parabola of different size, but the vertex or center is at the origin, just like this. Okay, this is what we call the directrix. For this case, we say the directrix is equal to x is equal to negative r. X is equal to negative r. X is equal to negative r. Okay, and then here it is what s. S is a, comma 0. Okay, so this parabola, it has equations of y squared is equal to 4ax. Okay, so that's the directrix. So if you do remember that you used to have a point, we choose the point just to find what to derive. We used this point in derivation. Okay, so then this is a particular point p x comma y. Then while m here, it is what is negative a comma 1. All right. So this is what this we call figure. This is figure 5.1. So this is what non-translated parabola. So there, the parabola is not translated. So, my dear student, I ask you to copy these instructions that will help you to be registered in our systems, in our educational and training system. So please pause the video, copy everything, because I want to use the space in order to transform your mind. So that is a non-translated parabola. It's a parabola whose vertex is at the origin. How now do we translate? So listen, let me explain before I draw it. So we can translate this parabola, possibly, can translate it from here, maybe along the x-axis to any other point, maybe here. So we call it translate parabola. Or you can translate this parabola by shifting the center of its vertex maybe to any point along the first quadrant. Or you can translate this one along the any point of the second quadrant. Or you can translate this one along any point of the third quadrant, and we can translate this vertex along any point of the fourth quadrant. So we have so many possibilities. And when we translate, we change all the properties of what? All the properties. The equation of the parabola change, and all the properties, the focus will change, the equation of the vertex will change, the vertex will change, the axial symmetry will change, except the length of lattice rectums will remain. Because, for example, here, the length of lattice rectum is a line which is perpendicular to the x-axis. So the axis of symmetry here is x-axis. So this is what we call a length of lattice rectum, which for here we get by taking 4 times 40 x. So that is figure 5.1. So ladies and gentlemen, now I want to translate this parabola into one of the possible process. Okay? So we say that a graph of what? Of translated, a graph of translated parabola. A graph of translated parabola. A graph of translated parabola. So you say that suppose the parabola in figure 5.1 is translated to the first quadrant. To the first quadrant. The first quadrant. So let me draw now the sketch. So okay, so let me balance this way. So this is still the y-axis. Okay. Then proceed because we still have. So this is the xy plane. We are taking the same figure, but now we want to translate the parabola. So this is still y-axis as we had there. This is x-axis as we had there. This is origin, remember. So you want to translate this parabola. So when you want to translate this parabola, one translate the parabola to this point. So this is the vertex. So it just is we are trying to sketch the parabola. Okay. So then so let me start from here. And then we have again, suppose that you have a parabola like this. It's the same parabola, but it's a little bit challenging for me to draw the same dimension. Maybe let me have a good picture like this. It's difficult to be accurate, but let us imagine like this one. So remember that this is what we call the vertex. Say vertex. So that is the vertex. So now we have our new vertex. So suppose the point for this, the coordinates for this vertex, it's, let's say V, it's what given as P, Q. So here it was what, remember, the vertex was 0, 0, right? So if we translate the parabola, everything is going to change. Now we can draw. So remember that when we translate the parabola, we have also to translate with its equation of directrix, because this is the constant distance. The distance from equation of directrix from this line to this line is the same to the distance from here to the focus of the focus of the parabola. So suppose that 1, 2, 3, 4. Okay, so let's say here is the focus. Then 1, 2, 3, 4. So somewhere here, we have a equation of directrix. Okay, so this is the focus. So it means that here we do have equation of 40 of directrix. So this is equation of directrix. This is equation of directrix. So the equation of directrix, we say that this is directrix. So with this directrix, we say that x is equal to negative a plus something. It will be changing. The equation will be changing. So plus something, because everything is going to change. So then here we have again a new axis of symmetry. Okay, a new axis of symmetry. So this is not the x-axis. The x-axis is this one. This is x-axis of 40 or symmetry. And then here we have focus. Remember that focus in coordinate geometry 2, we call it, or it means either in ellipse or in parabola, the focus we label with S. So S here will have a certain coordinates. Okay, so that's another point. So in case again we want to derive its equation, okay, so we can take any point along the locus of a parabola. So this is point at P. So here we have x, comma y. Again, we have to think about lattice length, about lattice rectum. So this is the lattice rectum. We have to think about its length. We didn't change the size of the parabola. So the length of lattice rectums for the translated and non-translated parabola will be the same, which is 4a, because we didn't change. We didn't maybe increase the size of the parabola or decreased. In case you find that the size of this parabola is not the same with this one, it's because of the manual drawing. All right. So this is a question of the directrix. Here we have a focus. Originally, we said that the focus is a, 0, but for this case now, it's not that one. So we have a certain value. So we have a vertex which is P, Q. This is the vertex, like that. And then we're going to have another equation. So remember that also we say that the lattice rectum should be perpendicular with axial symmetry. And this one is called the axis of symmetry. a line which divides the translated parabola into two equal parts. So this is what? Remember that mathematics is a graphing subject. This is figure 5 and T2. So this is representing what? Translated parabola. So the ordinary diploma students has to know it, and also undergraduate students has to know it. And also advanced secondary students has to know and master it. In case you have any question, don't hesitate to ask in the comment section, please. Okay. So now we have a sketch or a figure of translated parabola. So remember that I told you that parabola can be translated into millions of the points. It means the vertex of this parabola can be translated into millions or billions of the points along the XY plane without any effect. Okay? So it's not that it's not common that the parabola should always be translated at this point. No, that's not true. Okay? So if that's the case, we say that we have to think first of all on how we can reduce the equation of translated parabola. Okay? Question of the translated parabola. So that's the next concept. Equation, standard equation. So this we go to standard equation. Standard equation. Standard equation of what? Of translated parabola. Translated parabola. So we used to get this standard equation of translated parabola from the concept we call in mathematics translation principle. Okay? Translation principle. So you say that the parabola y square, because this is parabola y square is equal to 4ax, is being translated by what? By a factor of what? By a factor of p, q. We mean about what? The vertex p, q. Okay? P, q. So p, q. So the parabola y square is equal to ax is being translated by a factor of p, q, which we call the translator. So we say that according to the principle of translation in geometry. So we say in geometry, the image of the parabola, this is according to the principle, parabola y square is equal to 4ax. So the image, because it's shifted, so suppose that you put a mirror there. So it means that this is an object, this is an image. That's what we call it in geometry. Okay? So we say that the image of the parabola, this one, is given as this. Y, what the value of y in translation factor? It's q, because this is x, y. So it's q. So y, before you square, we have to reduce it by q, then we square. Then we have 4 times a. We have x, right? So this x, we have also to reduce it by the translated, the x translation factor, which is p. So you have x minus what? Minus p. So simply say that the image of the translated parabola, the image of translated parabola y square is equal to AX is given as y minus q square is equal to what? Is equal to 4a x minus p. Right? So the image of the translated parabola is what we call in advanced mathematics or in coordinate or in coordinate geometry 2, the standard equation of the translated parabola. So that is what we call the standard equation of the translated parabola. So therefore, the standard equation of the translated parabola along positive x-axis is given as y minus q square is equal to 4 times a x minus b. So this is very, and there's no need for you to expand the left-hand side expression. Don't expand this one. That's the standard equation you have to keep in your mind for the rest of your life. But remember that this is if the translated parabola lies along what the translated parabola. Therefore, the standard equation of the translated parabola lies along positive x-axis is given by that one. Wonderful. So that is 1. So this is 1. Then 2. Because I will give you the quiz right now. 2. So 2, we say that the standard equation of a translated parabola lies along positive y axis is, we have to recall the general equations of the parabola centered at origin lies along the positive y axis. So the general equation is x squared is equal to 4b1. So we use the image. So to find its image, so the image of this parabola, then we have to reduce the coordinate x and y with the corresponding translation factor. So here we have x. So what its corresponding translation value, it's p. So I say x minus p, then we square, is equal to what? 4. B, it is constant. Hence we have y. What its translation factor of y? What the translation factor of y? It is what? It is q. It is q. So simply the standard equation now, this is given as x minus p. There's no need for you to expand. Is equal to 4b y minus q. Okay? Minus q. So let me give you the quiz. Then we'll go back into the other factors, the focus and the other information. Okay, but I think that yes. So now let me let us pay attention before even we go. I mean that we say that these are terms. How did we call this one? Important terms in coordinate geometry. Okay, so we say that, how do we call this? We say, yes, okay, we say that parameters let's say parameters of standardly translated parabola along what? I didn't discuss on the negative x-axis and negative what? Y-axis. I will come back there. I forgot a certain concept here which you have to cover, right? So parameters of the standard translated parabola along what? Along positive x-axis. So we need some parameters which are very important. First of all, the standard equation, to remind you, it's the one we mentioned there. It is y minus q squared is equal to 4a then x minus b. So which parameter should we start with? Vertex. Say vertex. So the vertex of the translated parabola, the vertex is the point which divide the parabola into two equal parts. So the vertex takes the translation factor values p, q. So the vertex of the translated parabola can be formed as coordinates of p, q. That's very important. The second parameter which you have to think about. You have to think about what? Focus. Say focus. Before focus, it was given as what? As S. Let me check the style of writing. Yes, it was given as S. So before the focus of non-translated parabola, it had coordinates a, 0 for that case. But for this case now, we say that we had coordinate a, 0, which the focus of non-translated parabola when this parabola was at origin, the vertex of this parabola was at origin. But now we've translated it by the factor of PQ. So we have to add with what we have translated, because when we've translated it, you see the focus used it to be here. Okay? So this was the focus. So the x-coordinate here is not the same with x-coordinate here. So you see, the x-coordinates are not the same. The y-coordinate here was 0, while here the y-coordinate is not 0. It's a certain value. You see? So that's why that we should add. So in order to get the focus, we have to take these coordinates of 40 coordinates of the focus at when the vertex of the parabola is at origin. Then we add with translation factor, which is p, q. Okay? So how do we add this coordinate? Listen carefully. So the focus now will be equal to what? Take x coordinates plus x coordinate. So it is a plus p, comma, take y coordinates plus y coordinates. It is 0 plus what? Q. So simply, we say that focus of the translate parabola lies along what? Okay, lies along translate parabola, lies, so here I forgot, lies along. So lies along posterior x-axis. This will be finding by taking the value of constant r, then we add with the value of p, comma, 0 plus q is what? Is q. So that this is the vertex. This is the focus of 40. This is q. This is focus of that translated parabola. Right? Good. Then the third point we have to think is the equation of directrix. Say directrix. The equation of directrix, before translation, we had the equation of directrix on this side. It was x, you see? So right now, because we know its value, we can write here that a plus what? A plus q, a plus p, comma q. That's the focus. Okay? So the equation of directrix before, it used it to be x is equal to negative r. But now the directrix, before the directrix was possibly somewhere here. So it has been shifted. So because it has been shifted by what factor? It is shifted by the translation factor. So it means that for this case, but this equation of directrix is only having the value of x coordinates. So you see, suppose that the equation of directrix was here before translation, right? And then we shifted it from here to here. What did we change? We just changed the x coordinates. We didn't change anything about y coordinates because this line goes to the negative infinity and this line goes to the positive infinity. So we didn't affect the y value of the directrix line. So if that's the case, in the translation factor of p, q, we just take the coordinates of x for this case, which is what p. So it means x is equal to negative a plus what plus p. So that is the directrix of the translated what of the translated parabola. So you see that here I wrote x is equal to negative a plus what plus b because I wanted you to understand rather than cramming. Okay? So remember that even this parabola before means that you can sketch before translation, it was here. Okay? Just to advance now, to advance the concept. So to advance the concept because I believe that now you understand what am I teaching you. So kind of this. Okay. So that is about directrix. But again, we have another parameter. This is the first parameter. The first parameter is axis of symmetry. Say axis of symmetry. We mentioned this parameter, axial symmetry. The axial symmetry before, when the parabola was at origin, it was the x-axis. But when we translated the parabola from origin to somewhere here, we have a new axis of of symmetry. And this new axis of symmetry is corresponding to the value of y. So remember that at this point, the value of x is p, and the value of y is q. For that case now, we say that the axial symmetry is what? Is obtained when y is equal to q. Why? Because it's a line. So this line, the line is this horizontal line, its value is y is equal to q. And it is true in mathematics. The horizontal line has only the value of y. The vertical line, just like the equation of directrix, has only the value of x. Okay? So that's axis of symmetry. Another parameter which you have to discuss, we have to discuss endpoints. This is only one parabola. So you have to discuss this parameter for all the four possible parabolas. Means that a parabola lies along the translated parabola lies along the positive x-axis. You have to study also these parameters of translated parabola along the negative x-axis. You have to study for the parameters of the parabola lies along the positive y-axis. Then you have to study all of those parameters of translated parabola lies along the negative y-axis. So it's too much. It's more. So that's why that I insist you to understand in this parabola, and then you go further and you deduce for yourself. So the endpoints, right? So the endpoints of translated parabola. What were the endpoints? So you see the necessity of the quick review. What was the endpoints of non-translated parabola or a parabola centered at origin? So the endpoints were given as plus or minus 2a, a. So before the beginning, the endpoints, these are endpoints of what? Not of the translated parabola, excuse me. Endpoints of lattice vector. Endpoints of lattice vector of what? Of the parabola. So endpoints of what? Of lattice vector of parabola. So this used it to be plus or minus 2a. 2a, comma, what? Comma a. Is it no? This is wrong. The endpoints of lattice rectum for the parabola, for the of translated parabola, lies along positive or negative x-axis is given as a, comma, plus or minus 2a. A, comma, plus or minus what? 2a. 2a. Okay. So that is for the endpoints of lattice rectums of a parabola which is not translated but lies along positive x-axis or negative x-axis is given is like this one. So now this is the endpoints when the parabola is achieved, when the vertex of when the parabola centered at origin. When we translate this parabola from here to here, we affect also the endpoints, because the endpoints before translation, for instance, maybe it was here and this one, because this is the focus. So now we translate the parabola into this point. So this is the new endpoint, and this is the new endpoint. So this you can say that is A dash, and this is B dash. While this one was A, and this one was what? B. So you see that they do change. How are they changing? This they change according to the value of translation factor, which is P, Q, right? So to get the endpoints of lattice rectum, with this one we say that you have to take what? A plus P, so it is A plus P, comma, plus or minus 2A plus what? Q. These are the endpoints of lattice rectum of the translated parabola along x-axis. So this is what I want you to keep in your mind. Then we have again the sixth parameter of the translated parabola, which is length. So we have to discuss about length of lattice rectum. Length of lattice rectum. Okay? Say length of lattice rectum. So length of lattice rectum of what? Of translated parabola. Or translated parabola. So length of lattice rectums of translated parabola, this one remain the same. So say that. So length of the lattice rectums of the translated parabola lies along x-axis. Because if lies along y-axis, lies along x-axis. Okay, lies along x-axis. So we say that length, remember we said length, we don't change. So we say that length of lattice rectum of parabola or of any conic section does not change. Does not change. Why it does not change? That's a very important question. It does not change because translation of the parabola does not change. Does not change what? Does not change the size. Does not increase or reduce, that means change the size of what? Of the parabola. So if the size of the parabola does not change, then we say now length of lattice rectum for this parabola, lattice rectum we taught in session 4 will remain as 4 times 40 A. So those are the 6 parameters that we have discussed to enjoy the beauty of coordinate geometry 2 or the beauty of parabola. And the good thing is, these 6 parameters, we discuss them when we are studying the parabola. We are going to discuss these 6 parameters when we add up one parameter which is called the center. When we'll be teaching you an ellipse, so we have 7 parameters. We'll be teaching you about what hyperbola, also we are going to study these parameters for the particular hyperbola, where we have conjugative hyperbola, and also a normal hyperbola. Okay? So these are, you have to remember, because even questions will test you about your understanding on these parameters, and will test you about understandings on the graph of the parabola, and will be testing you on understanding of the equation of the translated or non-translated parabola. So that's the way, that's what we want to teach you. And you know that this shape of the parabola, just to tell you, to give you an advantage. You see the shape of this parabola, which structure, which useful structure in human life looks like this parabola. If you remember, or if you try to take this parabola, because we told you that we have a great focus and a great ambition to teach you on how you can solve real life problems. So now in the class we talked to you about the shape of the parabola. You are a great mathematicians of present and future age. So I challenge you now, in real life, in your daily life, when you are, and actually this does not need to be at home, maybe to be in what we say that maybe to be in mathematics, the mathematics lab. No. The good example of parabolic structure in our daily life is all around us. We have it in our homes. We can see it in our streets. So we have the structure. It means we have a structure which have the shape of the parabola and really employ the principles of the parabola. If you're watching these programs as a group of students, challenge each other. Which structure is teacher saying? Well, how can I relate? Let me help you, because I want you to enjoy the beauty of advanced mathematics and the beauty of basic engineering scientific mathematics. The structure is a dish, antenna dish, because I'm a telecommunication and electronics engineer, right? So we used to study different types of the antennas. Okay, we have a rod antenna, so we have so many. We have dipolar antenna, but one of the antenna is called a dish. So you have a satellite dish. We have also a dish antenna for the that we find in the, we call it in BTS. It means that best transceiver station, or in the telecommunication towers, or in communication towers. So you see the dish just like drums. So those dishes means that the drum itself is a parabolic shape. The dish of Adam, maybe if you are using at your home, your parents are using an Adam dish, or maybe we have against the other ones we call it DSTV dish. So just to go, so the structure of the DSTV, if the structure of the DSTV is the structure of the parabola. So the DSTV or the dishes use principles on designing the structure, okay, and alignments of those materials that he used to make a dish, use the principles of coordinate geometry, and use the principles of parabola. So you see that you can now think about, because you have to believe me, 10 years later, the mankind will get tired about the capacity of the present dishes. So you have to challenge yourself. 10 years later, what will be the best antenna dish that will be accepted or will be required by the people who will be alive at that time? Because the dishes you see nowadays, for example, the domestic dishes, DSTV dishes or other dishes, those are small in structure. But when you study the history of antenna dish, then or the history of the dish antenna, then you'll realize that it begins with a very big structure of the dish antenna. But the design, the principles, and the abstractions has been laid out to reduce the structure, to increase the performance, and actually that it means to increase this capability and just alignment and searching for the signal, searching for the line of sight, or searching for the maximum we call it maximum energy, or just say, okay, the transmission line. So you mean that if you go and read the history of dish antenna 50 years ago, you'll find that now our dish antennas of this age has changed a lot. So then we believe 50 years later, we will be tired to use the present dish antenna. So we need a new one. And I and you, we have to challenge ourselves about the future demand. That's are the problems that we have to solve. I think that you have enjoyed. That's a good example. So it means that we can discuss also these 6 parameters, okay, when the translate parabola is along y-axis. Okay, so this is what we have to make sure that you understand, because you can translate that parabola also along y-axis. So just to help you, okay, to help you. However, that I think it's better if you write, because it will help you. And then I'll leave the homework for you. Okay. Okay. Let me teach you quickly, and let's end this session. So a graph of translated parabola along what? Along positive y-axis. Positive y-axis. I want to show you, because in the question you may find you have only 4 possibilities. Whether the parabola had to be translated along positive x-axis, or the parabola to be translated along what? Along negative y-axis, or the parabola to be translated along what? Positive y-axis, or the parabola being translated along the negative x-axis. So suppose that we have this xy plane. Okay, xy plane. Xy plane. Okay, so this is y-axis. And then this is x-axis. X-axis. So this is center 0. Okay? So possibly we had what? We had a non-translated parabola of this size. So the center was here. So to translate this parabola along the positive y-axis, then now we can translate this particular parabola, but it has also it has its focus here, and possibly we have a question of directrix here. This is before translation. I want you to understand. Okay? So if that's the case, now we want to translate this parabola as a translation factor of P, Q, and its vertex now, instead of being here where we have origin 0, 0. So now we have our translated parabola at this point. This is our translated parabola at this point. We can also translate it at semi-quadrant or at second quadrant. So there are so many possibilities, as I told you. So ladies and gentlemen, if this is our interesting translate parabola, so we have what? We have 1, 2, 3, 4. Okay? 1, 2, 3, 4. We have 1, 2, 3, 4. 1, 2, 3, 4. Then so you have 1, 2, 3, 4. Okay? So then here we have the focus. First of all, we have axis of symmetry. Say axis of symmetry. So this is axis of symmetry. Axis of symmetry, ladies and gentlemen. Okay, so you have axis of symmetry. Just like this, it is a dotted line. This is the focus. Okay, this is focus. So this is focus. Okay, and this is vertex. and vertex has a translation factor of P, Q. Okay? Then here we have what the equation support that here we have our equation of what equation of Directrix. Wonderful. Equation of what of Directrix. So we have equation of the Directrix, which has been translated before it was here. So this is the equation of the Directrix, which is equations used to be y is equal to positive b. Oh, excuse me. This is, okay, let us translate this into negative y axis. Then we look for the positive y axis. Excuse me, because positive y axis is on this side. Excuse me, this is positive, this is negative. Here it is negative, this is positive. So in my mind, I wanted to do the translations along the negative y-axis because in x-axis we did it along the positive x-axis. And we leave the homework for you for the remaining sides of this. So this one we call it axis of what? Of symmetry. This is axis of symmetry. Axial symmetry. So this is the focus. So the focus has particular coordinates as we are going to discuss soon. Okay? And then, okay, we have our, so it will be y is equal to b plus, then c is parameter. So you have a vertex here. So remember that even in this equation, we can also take a locus of the point. This is point 30, so you can have again maybe a representation like this. So this is point P, x, y. And here, this should be perpendicular. Okay? All right. So what again we need? So this is what? This is figure 5.3. So what? Translated parabola along what? Along negative y-axis. So here we had a standard equation of the parabola, which was x squared is equal to negative 4by. So we are going to discuss it soon. So do you have every piece of information? Yeah. So we go into the parameters of what? Before the okay. So just to get its equation, right? So we say that the standard equation of this parabola, we just have to remember the standard equation of the parabola lies along the negative y-axis is given as x squared is equal to 4b1. We derived, right? So now the equations of means that now the equations of translated parabola will be x minus p square. This is equal to what? This is equal to negative 4b, then open bracket y minus q. So simply the equation of this parabola is what? X minus p square is equal to negative 4b y minus q. Okay? That's the standard equation. You have to remember that. So whenever you get or you be given any equation or any question that is dealing with this, and you find that compare by using this equation, then you have to know that this is a translated parabola along negative y-axis. Wonderful. So we can discuss about this. That's why that I was budgeting the space in order to use the same terms. Parameters of the standardly translated parabola lies along what? Negative now. Along negative what? Along negative y-axis. Along negative y-axis. The translation factor is what? P, Q. So the standard equation standard equation of the parabola. We have discussed there the standard equation of the parabola. It is x minus p squared is equal to negative 4b y minus q. The vertex is p comma q. The focus, second parameter, which is the focus, now we have to deduce it. Okay? So you have to deduce it until we get as how we did. Okay, what was the focus of this parabola? So the focus of this parabola is towards 0, negative b. Oh, okay, so the focus, the coordinates of the focus of the standard parabola centered at origins lies along the negative negative y-axis is this one. So you have to add it with translation factor, which is p comma q. So as I told you, the way of additions, you take the x coordinates, you add with c, corresponding to x coordinates. Then you take the y coordinates with negative b, you add with corresponding y coordinates, which is q. So 0 plus p, so this will give us, it is p comma negative b plus q. Remains like that one. But if you have the values of p, b, and q, we substitute them to get the focus of the parabola. Then you have equation of what? Directrix. So equation of directrix, for this case, when it was here, when you had this parabola here, it is y is equal to positive b, right? So y is equal to positive b. So y is equal to positive b. But now, this directrix has been translated. This directrix, question of directrix has been translated to this point. So, did we change the values of x? No, because the values of x, the lines goes to the positive x value, and also the values goes to the negative infinity, and then these values goes to positive infinity. But we changed the value of y. So the value of y at this point is not the same with the value of y at this point. So what will be the magnitude of value of y? What the coordinates? So in translation factor, what the coordinates? So it means that this translation has been made by the factor of q, means by the point of q in y coordinate. So y is equal to b plus what? Q. This will be the standard equation of directrix of the translated parabola along negative y-axis. Wonderful. Then we need the axis of symmetry. So the axis of symmetry for this case, we drew this dotted line. The axis of symmetry, this one, is perpendicular, it's parallel with the y-axis. So if it's parallel with the y-axis, the axis of symmetry before it was y-axis. When you translate it, means the axis of symmetry right now it's no longer what the y-axis, but the axis of symmetry now, we say y is equal to q. The axis of symmetry, y is equal to q. Axis of symmetry, yes, y is equal to q. Y is equal to q. So it is what? So even y is equal to q. So change, please. I think that in the previous parabola we made a mistake. It was x is equal to p, not p. It was x is equal to p. So here y is equal to what? To q. Then we go for the endpoints of lattice spectrums of this parabola. So we have to recall, okay? You have to recall that the endpoints of the lattice spectrum, the endpoints of lattice spectrum of the parabola before it has been translated, which lies along either positive y-axis or negative y-axis. If you do remember that we found they were negative plus or minus what? 2b, comma b. Okay? Remember that the lattice spectrum is a line passing through the focus and perpendicular to the axis of symmetry. So that is lattice spectrum. So it is positive 2b, so positive 2b. So for example, this is means that it depends. So you can find that this is positive 2b, comma b, comma negative b. Okay? and then suppose that this is negative 40, 2b, comma, comma b. So if that's the case now, we have to add with translation factor. What the translation factor? Because this lattice rectum, when the parabola was here, the lattice rectum is here. So when we translate, also we move it. So so it means the translation depends on the value of p, q, right? So pq. So if that's the case now, ladies and gentlemen, the endpoints of lattice rectum of 40 of the translated parabola will be plus or minus 2b plus what? So take the coordinates of x plus coordinates of x plus b, and then take the coordinates of y, which is b, plus the coordinates of 40 of q. Wonderful. So those are the endpoints, because I told you these are fundamental and the core parameters of every conic section of the parabola, ellipse, and and hyperbola. So we'll be singing this chorus. If just you are singing like a song, this is the chorus. The parameters, the question of the conic sections, this is the chorus. Even the questions, because in the next session, session 60, which is lecture 60 for ordinary diploma students, actually I will teach you how you can solve some problems of the translated parabola. And realize that actually what I've been teaching you, we realize that the foundations that I've been building on these 6 parameters will actually give you ability to approach and solve so many problems more than expecting, right? Okay, so then we come for the length of the lattice rectums of the translated parabola lies along what? Along either positive or negative y-axis. So it says the length of lattice rectums of the parabola does not change of any parabola. Of any parabola. The length of any parabola does not change because the translation process or the translation parabola does not change the size of the parabola. Okay? So therefore, the length of lattice rectum of the parabola lies along y-axis. Before it is being translated, it was 4b, and the length of lattice rectums of the translated parabola along y-axis will have the same value, which is 4 times b. That is. Have you found? Does it make a sense to you? Do you understand? Do you understand what am I teaching you? Tell me in the comment sections, please. Okay, so ladies and gentlemen, yes, what I've taught you, the Lord is telling me that Olenjolai is enough for today. Because I can overdose. You can find that now, instead of absorbing these materials, you are saturated. And I don't want to destroy it because we still have a long journey. This is just the first chapter among the 8 chapters, 8 topics of advanced mathematics from 60, right? And again, that this is just the second chapter among among the 4 chapters that we have to teach ordinary diploma in conics. So we still need you. We still have a lot of things to do ahead. So I don't want to saturate you. This is enough, according to what I've been told by my creator and my manufacturer, my employer, my employee, the one who has employed me for the rest of my life, the one who has made me in his image and likeness, that is Elohim, God of gods. Okay, so it's telling me it's now. So it's the time now I have to give you the homework. Because I know some students have been praying for me to forget the homework. No. My classes without the quizzes, without the homework, will be incomplete. So this is, ladies and gentlemen, homework, which you got in HW. Homework number 5. I have 2 questions. Okay? 2 questions. The first 2 questions are, we say that use the graph to show the translation of the following of the parabola along a negative x-axis and b positive y-axis. That's the first question that you have to answer. I taught you when we translate the parabola along the positive x-axis, and I taught you when to translate the parabola along the negative y-axis. So this is Roman 1, and then this is Roman 2. Then we have B. So we say that the views so we say refer graphs of what? Of Roman A 1, Roman 1 and 2 above. Then use all 6 parameters of the parabola for each graph. I want to tell you the secret. If you concentrate and do that homework yourself, right? If you concentrate and do that questions yourself, believe me, you will understand this concept extraordinary and for the rest of your life, because you will be discovering challenges, issues which are a little bit complex and confusing, which most students they use to discover them in exam. They don't discover them during the study because they don't have a good methodology or a good arrangement on how to study the concept. So during the preparation of exam, because they are doing fire extinguisher, so you find that they encounter those challenges which I have tried my level best to share with you or to reveal in your mind at the beginning of the program. Or it means that during the class sessions, before even yourself, you went to do the further studies. So make sure that you do that homework and you do it for your own benefit, not for me, for your own benefit, for your own success. So thank you. This is the end of session 5 or lecture 5. I thank God who have created me in his own image and likeness. I give him all the glory. I am his child and he is my father. And I thank God who have given the opportunity to join me from the beginnings of session 5 to the end, or from the beginnings of lecture 5 to the end. I thank you whether you are an ordinary diploma student of NTA level 5 or you are an advanced secondary student of pre-form 6 or form 6 in any school, in any region of Tanzania or internationally. I thank you very much. I would like to invite you to join me in the next session 6 or lecture 6, where now I will be teaching you how can we solve and how can we find these 6 parameters according to the equation of the parabola, of the translated parabola, which will be given. So we are going to deal with different examples, or more, at least 5 examples that will be solving about the translated parabola, so that you understand how questions are being asked. But I still challenge you that whenever you study parabola, think about dish antenna. Okay, think about how you can take that knowledge and add up with telecommunication knowledge in order to design a new dish antenna, or to maintain, just to do something, to contribute something for the humanity, which actually that many people, they do fail to contribute, or they see that it's less valuable. But yourself, you have to see valuable like these programs. Many people, they used to see that it's less valuable, but to me, it's the most valuable for the rest of my life. So thank you very much. Remember to register yourself by subscribing and choosing the options of all. Remember to share these contents with your classmates, okay, with your schoolmate, with your college mate, with any students in Tanzania, in Africa, in Europe, in America, in Asia, in Australia. Share with them. Share that these secrets, because really this is secrets. So share with them. Again, remember, Sir Olenjolai does not know everything about coordinate geometry too. Again, Sir Olenjolai does not know everything about conics and the differential questions, which is basically engineering and scientific mathematics. I know small portions of those modules or those courses or those subjects, but I have an assignment to teach others what I know. That's all. I'm learning new concepts every day in mathematics, because mathematics is a very important subject for the rest of my life. So I do love mathematics. How about you? Tell me in the comment section, please. I do love. I used to love mathematics. I still love, and I will keep love, because really it's changing the way I think. Actually, it is speeding my level of thinking, my level of predicting. So actually, it's giving me so many applications, so many advantages for the rest of my life. So until we meet in the next session, join me in the next session. May God bless you. I used to pray for you, and I ask you to pray for me, because you heard that. For example, in Tanzania, online advanced secondary school in square bracket Olenjolai&Nekinyi, we have a vision of contributing into the present and future generations more than 600 videos. It's intensive work, because I'm doing a work of 68 teachers of advanced education. And also in ordinary diploma, I'm doing a work of 8 assistant lecturers, or 8 tutorial, more than 8 what we call them tutorial assistants or assistant lecturers. So I'm doing the work that actually a number of people used to do. I'm not saying that in order to boast myself. No. Everything that I do, all the glory and honor should be given to God of Abraham, Isaac, and Jacob. Right? That's all. So I have nothing to boast myself, because it's God in me that teaching me. Believe me. It's not my mind, it's not my intelligence, it's not my experience, the schools that I studied, the degree that I have. No. All of those, they have less contributions. But the great contributions is the grace of God. May God bless you and keep you until we meet in the next session. Don't miss it. Enjoy the beauty of advanced mathematics and basic engineering and scientific mathematics. Stay tuned, stay focused, stay serving your purpose, or get prepared in order to pursue your purpose. And may God bless you. And this is a national teacher, Sir Olenjolai&Nekinyi, who loves you so much. May God keep you, and welcome in the next session.